All right. One thing that happens is network proxies. Be aware of this. Using this link right here, we're working behind it. That's important to note, that you want to make sure that you look at this in order to solve that. Yes, it is indeed. Do not try and reuse the same shell environment when moving between copies of the build system, because it has the wrong paths and stuff like that. So every time you move between them, you want to go ahead and rerun the OE init script from the top level again. Make sure that you're at the right spot, because otherwise you'll be linking to the wrong thing and you'll be frustrated. OE init build environment script does append to your path. It's a result of a cumulative and can cause unpredictable build behaviors. And I've seen this before, especially when you're trying to go between multiple versions. So be a little bit careful of that. Generally, what I do is I try and create different sections. One thing that I've done is I always run at least 3 terminal sessions, 1 to do the editing on whatever it is I'm actually doing, working on, 1 to work on recipes, and 1 to actually run the environment and run the builds. So I generally run 3, and that's just been my workflow. We used to have an IDE. There's a new IDE. I haven't played with it. I'm not really an IDE person, but it's available, and I'm refresh my memory again on the new version. Yeah, VS Code. Yep, it works in VS Code. So that's what it is. Yep. So that's nice to be able to do that. It will be, I think, but I don't know the details on how it's going to be accessible. I haven't seen those, and I'm just providing the content, unfortunately. Sorry. Yeah, how it's going to be accessed, I don't know at this point. Somebody else may know that. Right, there you go. That's the answer. That's a good answer. Do not try and share the shared state cache between hosts running on different Linux distributions, even though they say it works. Matter of fact, don't even try and share shared state cache between 2 people at the same time. Now, you could probably get away with it if you could probably get away with it if you're actually using different architectures. You probably could get away with it, but I build for 6 architectures at a time, and when I need to start over again and build my build things, I go ahead and build the common things with 1 stream. So I literally start 1 builder. I wait for it to get through. I wait for it to get through about 1/3 of the entire build. I make sure it gets done with the and when I say 1/3 of the build, I'm referring to first building for all of the tool chain pieces ahead of time, and 1/3 of the way into actually building for whatever architecture I'm building for. That makes sure that all of the native things have already been built ahead of time. So, I mean, and I'm doing that. The project I'm working on is I work on meta open embedded, and I do the regression for that. I maintain the servers that deal with that and the builders that deal with that, and they're offline right now. We're rebuilding our big file server, and that caused a little bit of a problem. So, but we build 6 at a time. Actually, we're building 6 right now. So we build x86, x86 64, ARM 64, and then the two new RISC-Vs, both 32-bit and the other one. Yep. It turns out that I'm able to do it because I do different architectures, it works fine. If I wasn't able to do separate architectures, it wouldn't be working. It wouldn't work fine. So we get away with it only because of that, because each one of them is a completely different architecture. But in general, the answer is no, it does not really work. I've not seen it. And again, like I said, because I want to make sure I build all the natives first, And that's what happens is it'll build the natives for me. I wait until I get about a third of the way through before I start the other architectures to make that work. So that takes care of that. That's pretty common gotchas here. Oops, here we go. It's an open source project. There is a lot of things that you can get to. Yocto at Yocto Project and Pocky at. So there's a whole bunch of email mailing lists. OE Core, for example. They all have public code repositories. There are private repositories, but those repositories are they're still public. People see them. You know, RP has them and Zeddy has them and some of the other folks who are working on the different pieces of it, but they may be their own repositories that are used primarily for staging and for working on things, much as Linus and Greg Hartman do as well. So you're going to see things like that. There is a Bugzilla for it, so you can go ahead and look and see what's going on. One of the places, if you want to start contributing and helping, is take a look at the Bugzilla. They've identified a number of them that are what they call newbie bugs. That is, they don't expect you to be an actual super expert at it. And if you want to contribute, that's a good place to start. These newbie bugs, there's a mailing list that talks about that and says, hey, we got all these newbie bugs and here's where you find them. And you can click there and it does the sort for you. So that's kind of nice. You have both get.yoctoproject.org and get.openembedded.org. They work together. They are in fact two different projects, but you'll find Open Embedded Core in one place and BitBake development in a certain place, but those are the things that are happening there. Yocto itself has a number of pieces, including Toaster, including if you take a look at their Git repository, you'll see an auto builder that's available for you. It's based on again on Python. They've settled on Python for pretty much everything. But the two projects, you'll have to look and see what layers things are in. For example, if you go to layers.openembedded.org, you'll find out that some things are in, some layers are being maintained directly by the Open Embedded project, or are in their repositories, I should say, like Meta Open Embedded or Meta Open Embedded and Meta. Those are there, but you'll find that other things like Meta Pocky are being done over in the Yocto project ones. And the layer index will show you that, layer.openembedded.org. You can find it there. You also have to note that there's also things such as documentation, very well done documentation. The Yocto project has really worked hard to make things happen in a way. The BitBake manual is far better than when I started, obviously. They've done a super job on that and on how to use Yocto and all the options and all the other pieces. So that's really nice. And that's available at the documentation site, which I think is yoctoproject.org/documentation. We'll see that. You can use grep here, which allows you to grep for the relevant use cases. It's designed for code search. It knows about different kinds of things. It default skips .git directories and stuff like that. It can be taught arbitrary types if you need to. It's really great for searching metadata. You can see that. So for example, you can go ahead and use this here. I don't know that I can. Can I move it? I don't know. Can I move the toolbar? No, it doesn't let me do it. Unless it tells me I can move it somewhere. Nope, I can't. For whatever reason, it doesn't let me move it. It allows me to do this. Oh, okay. How about that? And oof, that's terrible. That's awful.
Well, it's getting worse every time you touch it.
Yeah, I can see that. As a matter of fact, I think I'm locked up. Okay, there we go. Now let's. Okay.
But there's also a black box.
Yeah, now it's even worse.
From the document.
Now it's even worse. Let me do that. See if it. No, it didn't. Okay, how about that?
Now it's fine.
Now, great. Okay, so let's go on back here. Right. Okay, so you can go ahead and look at things. That's important to find things. So if especially because we're searching metadata trying to find certain things, this is a good thing using grep here. So if you want to use that, so alias bback is doing this, type bitbake here. So we're going to look for source URI, and then you can find where it is, different versions of it. If you want to find a specific thing that you're looking for, especially good for like grepping through this here, like MTD utils PV, you're trying to find where that is. Boom, use this bback, and it works really kind of nice as far as that goes. And you know, most of the time we're actually going to be searching through metadata anyway. All right. Vim also has a syntax highlighting for it. There's bitbake. There's a version of it here. They've contributed to that, so you can go ahead and add that as well. And you can go ahead and see the various things. Makes it a little bit easier to once it's highlighted. So you can look at it here. You'll notice that it looks like this. So it knows what a BB is or what a BB append is, for example, and it'll go ahead and do things like this, make things a lot easier for you. How much did you get into inheritance? There's a number of things. There's Cardinal, for example, auto tools. I know you talked about that in that. You'll notice that it inherits get text. Get text is allows you to make it so that it knows that it has to use get text. It's another inheritance thing. It's also for parsing. Let's see, which one are we doing here? GNU core utility. So this is GNU tils, right? Yeah. So you can see where you're getting it from. Good. Talked about that. That's great. Glad, because inheritance is one of the bigger tools for this. We're going to talk a little bit about kind of a specific board example. The Minnow board is an x86 board. We're going to talk about that, just kind of how do you kind of start things out? Let's talk about a little bit about board bring up using this. You'd of course get the Pocky. You get the Pocky distribution, which includes bitbake and a few other things. You go ahead and get the meta intel layer because you need that. Well, it turns out also that Meta Yocto BSP also happens to know about it because it's one of the 5 boards that are supported. So it turns out that the Minnow board is the board that you use, that you would use if you're going to do an Intel as your base system here at x86 or an x86-64, if you will. Both of them are supported for ARM. It uses the beaglebone black. It uses a router for MIPS. There's a router that's made by UI, by Ubiquity. So this is one of them. You can also get it from Meta Intel. This would be your BSP, right? From Meta Intel. You're going to go ahead and get the information that you need from there. You're going to get that Meta Intel layer. It'll include video things and other things that you might not get from the base layer. And the base BSP, you're going to go ahead and add this to your BB layers so that it can be parsed, and so that the BB appends and all of the configuration bits can be read. You're going to go ahead and tell it that the machine is now an Intel Core i7-64, and then you're going to go ahead, but that's funny because I don't think it's really a Core i7. It's something else. And then you're going to go ahead and add that in as the machine. You'll notice that notice in this particular case, you're defining it as this is the machine we're going to build. And then you're going to go ahead and build your core image minimal, which should create all the pieces that you need in order to be able to boot this device. Are there any questions on that to this point? Okay. There's actually some more things that you've got to deal with, right? Because you got to be able to download it. Remember that this thing has an SD card slot here. So you'll put it onto an SD card. So you're going to have to use WIC to actually put it on the card. It's you have to make sure that the Kickstarter file for this particular Minnow board is available to you, and make sure that you use that so that you get the right image style, because this uses EFI for its boot as part of its boot. It's EFI, so that's a little bit different into where things go. As far as that goes, let's see what else you have to know. You can use the serial port header and talk to it initially, but of course it does have HDMI as well, a little micro HDMI, and it has USB, so that you can have so you can also use a display along with the USB keyboard and mouse. You can do with that. This header over here has got serial ports and GPIO and other things on it as well. So I believe this is a camera port, but I could be wrong on that. So for the SD card, you can do a DD instead. If you've got the whole image there, and it'll actually drop it on there. You can connect to the serial and boot. Again, you don't have to have the video working at that, but you go ahead and deal with it that way. So you're going to find the actual images for this in temp deploy images. This is in your build directory. So you're going to build for the beaglebone, or rather for the minnow board. You can create a UANV start with saying minnow, and then you go ahead and use minnow temp deploy images to find it. There are already made SD cards that are part of WIC. WIC actually knows how to deal with this, knows what the partition sizes should be, knows what the partition type should be, all of the other pieces, and then knows how to pick up all the different pieces, the correct pieces to get it booted. You'll notice that this is using EFI for the booting, and you're going to boot this boot x86 EFI. Okay. Now I realize that this is a fast version of it, but this is essentially what you're going to do with whatever board. You're going to create an image, you're going to create a bootloader, you're going to create a kernel. You're probably going to start with the bootloader and a serial port and make sure that you can bring it up. Again, we can do that as well. It does not have to be done inside of Yocto, but you can easily do that. You can tell it to just bit bake specifically the bootloader piece of it. You can then go ahead and make sure that that gets transferred across to your whatever your media is, and then go ahead and attempt to get at least it's coming up to where you say, okay, the bootloader says that it can see everything. So that's a good place to start, for example, the same way as you do any other embedded development. Okay, any questions on any of that? All right. There are other boards as well. There's Dragon board, and there's a whole bunch of other ones. These are from the 96 boards group. Beaglebone. Anybody playing with a Beaglebone or Beaglebone Black? Yeah. So what's one thing that's very nice to note about the Beaglebone and the Beaglebone Black especially is, and indeed any of the Beaglebones, is they use a vanilla kernel. They have no patches whatsoever that are necessary in order to make it boot and make it run. So it is wonderful from that perspective. You don't have to worry about it. Bring a plain vanilla one, configure it for being the EVM, add a few options that make sense for you in the kernel, and boot it. Build it up and boot it, and it works just fine. So that's really kind of nice. Same thing here. You're going to end up with the same thing here. You're going to end up with having the downloads. There's your releases. This is the Beaglebone itself is one of the supported architectures. That is to say, it is the example for hardware of ARM variety, ARM 32. So we already know about it. We don't have to go get the Intel version of anything or the ARM version of it from anybody from MetaTI or something like that, because it's already part of Pocky. It's already part of actually it's part of Meta Yocto BSP is what it's a part of. So that makes it easy. You just tell it the machine is a Beaglebone and off you go. And you can build it. Again, this has a serial port. Its serial port headers here, so you can bring it up with the serial port header, some Ethernet here, some USB over here. So whatever you need, very fast. All right, now I'm going to go ahead and get something else. We're going to talk a little bit about kernels here since we've got a little bit of time. So let's do that. Hold on a minute here. Okay. Did you send that to me, Bian?
Sorry, what was that?
You're going to send me the kernel one. Yes.
Oh, what I meant was I meant the other hands-on talk. I don't have that. Those slides.
Oh, you don't have it. I thought you did.
No,
okay,
no,
never
no.
mind.
Those are Bruce. That's Bruce's talk.
Ah, okay, never mind.
Yeah. It's okay. It's all good.
No, never mind. I just want to make sure I was on the right place there.
Yep.
Okay.
It's all good.
Yep. So do we have any questions at this point? About anything that we've talked about to this point? Okay. Is it clear on using layers and what you might put in each individual layer? So we're not going to modify meta. We're not going to modify meta Pocky, but we may copy it and use it as a starting place, right? We'll make a copy of the entire directory and we'll change it to some other name, and it'll become meta foo or meta whatever your particular distribution is. Then the BSP will come from wherever it comes from, right? It'll come from your vendor. You'll do it yourself if you need to, but that BSP layer. And then the rest of these are optional, really. The first three are you're probably going to end up having in every single one. Can you put your application in your distribution layer? Absolutely. There's no reason why you have to put it up here in some developer layer. If you're responsible for the whole thing from top to bottom and all you're doing is splitting it out to make it look pretty, why bother, right? You don't have to do that. It might be easier, especially if you expect to hand off a piece of it, right? I'm going to have developers who are going to work on that. As a systems programmer, you may yourself need to go ahead and do the whole thing. Oftentimes there are developers who are going to develop the final piece of it. You know, they're doing it as you know, web developers or whatever you're going to do, or maybe they understand Qt better than you do and are working with that. Okay. Well, because yes, exactly. Right. It's really a question of should you keep the player separate, like the developer layer separate, so that you can hand it off to someone else easily. That's the typical way I look at it. Is am I going to be responsible for it from top to bottom? Is more than one person going to be working on it? If more than one person is going to be working on it, then they get their own layer. It just makes life a whole lot easier. It means also if their layer comes in, that you bring it in, you add it, you try and build it, and it blows everything up or it breaks things, you can say, go back and fix this. I can continue to work on whatever layer I'm working on, continue to develop in that particular layer, and fix things that are my responsibility that are broken. So separating them out is usually the way it's done. So let's talk about inherit. Yes, I see the inherit. So because we're using Python as our interpreted language, we have the concept, we have the object-oriented protocol style, the object-oriented style of programming available to us. And so we can inherit essentially, you might as well consider them to be additional functionality for it. So you're adding the functionality of for example, kernel. Well, the kernel knows about how a kernel is configured. It knows about the fragments. It knows about, it knows that it has to get certain things and they have to be done in a certain way. Building the kernel doesn't completely use doesn't do things in the normal way. Also, in addition to that, it knows about things such as make menu config. So for example, you can go ahead and use make menu config to do your configuration changes so that you can do the temporary changes that you would expect to see happen. And then go ahead and build that. And then once you're done with the build, then you can say, okay, this is going to become my def config, for example, because I've made it to where that I have all the pieces I want and all of the patches that I need to have for that kernel. Does that make sense, Darius? Yeah, good. Okay, so the difference between that and includes. Okay, so let's go back to where we get to that. Hold on a second here. I think that's back here. Okay. All right, so let's talk about here. Okay, so inheritance inherits Python code or shell code. Includes are files that are going to be used for usually for things such as configuration bits or additional things that you need, for example. So they're things that are going to be included in the, typically they're not binaries, they're not source code, but they're rather other bits of information that are going to be needed to be put in certain places when the install process is done. So it has a place where you include that file wherever those files are.
If I may,
Go ahead, please.
Yeah, if I may, I was writing a comment here and I thought perhaps I'd just say it is that think of inheritance as a standalone beginning of a recipe. So if you're writing the same recipe over and over again, and there's a framework around which you can build out a recipe, that becomes a BB class that you can inherit from. So it provides things like same defaults and specific tasks and other things like that. It's a reusable basis for a recipe. Think of, I don't know if you've ever baked cookies. You always start with butter and sugar and flour. The rest is details, but there's always a starting point to make cookies. That's exactly the same, regardless of what cookie you're making. That is a BB class. That is what you inherit from. All cookies start the same way.
Right.
The idea with an include or a require is you have a series of recipes that where like 90% of it is the same, and the differences are extremely minor, but the things that are the same are sort of in the middle. It's a bit like I'm building a house and I'm building a garage. They have walls, they have a roof, they have all this other stuff, but one is plumbed in for water and electricity and sewage. The other one's only plumbed in for electricity. That there are marked differences, but there is no is-a relationship. Okay, they're both buildings, but one is a house, one is a garage. Right, and so the similarities can be put into a include file and included in both places, but it's not an object relationship. It's just we're doing the same things in two different circumstances. It's convenient to put it into an include file, and typically include files live within a package. They live within the recipes directory, and they're used for making a series of recipes that are practically the same, except for one or two lines of code. Classes and inheritance comes from the classes directory. It's used cross package, cross recipes. In some cases, cross layer. You don't tend to use include files in that fashion. So again, the litmus test is always is it an object relationship, or is it a header file like in building C code? Is it a convenient place to put reusable things, or is there an actual, like I said, an is-a situation? So for instance, if you were in a situation where you're using auto tools, there is an is-a relationship. Is this recipe an auto tools recipe? Yes, it is. Therefore, we inherit from auto tools, right?
Right.
That you always have to look at that kind of relationship. If we're including some settings that are the same across three recipes, it's not an is-a relationship anymore. It just so happens that we're writing the same, let's say 10 lines of code in 3 different recipes within the same package. Therefore, it's just an include file that we can maintain in one place. It seems like an arbitrary difference, but once you understand that one is an object relationship and one of them is just an include file, there's a fundamental difference in where you're going to use them. They feel like you're both just cutting and pasting code into a particular location, because that's how it's implemented. But like I said, one of them is in fact and is a relationship, the other one is not. Does that make more sense?
Yeah, and building on that, is a kernel recipe, is a
Yes.
it is a kernel recipe, is a recipe that uses auto tools, is an image file that you're creating an image file. So this is an image recipe. We're going to inherit core image because we're going to use a group of package groups that create a core image that would normally be used to create a core image.
Exactly. Whenever you're dealing with object-oriented languages, that's always the question to ask is, are you including a member into an object, or are you making or inheriting from another object to make a new object that's related? And that is always the litmus test to decide whether or not we include a variable into the object or whether we inherit from that other object. So you have to look at that as a situation.
Okay, let me look at this. Hold on a second. Yes, when you say a limited database of things, they are all the things that are in class directories scattered throughout the entire repository, or the repositories that are included within the BB layers. So, for example, everything that is a class file, you can inherit a BB class from a different layer, for example. That's not unusual to happen. If you include that layer, that BB class, any classes, BB classes that are in the BB class directory or in the classes directory of that layer are also available across the entire build system. Right, is layers to classes. That's correct.
It's worth mentioning that classes are listed in the layer index. So actually, if you could pull up the layer index, Tom, you'll see that layers, recipes, machines, which are BSPs, classes, and distros are all listed there. And I apologize for background noise. There's somebody with a leaf blower outside my window.
Of course. What I did was I got rid of something that really bothers me. And now I can't find it. Oh, there it is right there. Okay, brought it back. Sorry about that. I was in the wrong place. Pretty sure that's it, right? Yep. Okay. So if you take a look here, you can see there's layers, recipes, machines, classes. So here's our classes. We can go ahead and search for a class. We're going to go ahead and search for kernel. Okay, we're going to do a search for that. You'll find that Anaconda kernel, you'll see that there's a bunch more kernel. There's one right here. There's a kernel class that's for Open Embed Core. Right, so that's the one. So that's the kernel class. You also see that Open Embedded Core, that Meta Web OS OSE also has its own kernel class because it has to build things slightly differently. So you'd inherit that particular one if you were building Web OS SE, OSE, Open Source Edition, for example. It's often annoyed me that they didn't call it kernel something else, or like they were doing here, kernel_Android, but they didn't. Yes, you can do encrypted disk partitions and image builds. That's generally speaking done as part of the, not as part of the packaging process, but as part of the image creation process that's done at using the Kickstarter mechanism. So you can see different machines. These are the supported machines. So for example, we can put in here beaglebone, and you'll find that there's probably a lot of them. There's a green, there's a black, and there's a whole bunch of different ones. And you can see that they are actually being done by different groups here. They're part of different layers. I don't know how much B3FS and XFS are supported within the community. I know Kickstarter does know how to deal with that. Kickstarter, comes from server space, so it handles those bigger file systems quite well because it's designed for it. Now, how much support there is for B3FS, I don't know. I haven't actually tried it ever. Go ahead.
Yeah, I would mention that neither butterfest nor XFS are, at least in my experience, used very heavily in embedded. The XFS is a little overkill for most embedded systems unless you've got very large, unless you have to deal with very, very large files. XFS is massive overkill. Butterfest has some unique issues, which is one of the reasons why XFS is used very heavily by certain distributions. So I would, Butterfest is certainly a file system a lot of people would like to use, certainly in the embedded space and others. Android was looking very, very hard at using Butterfest for Android, for instance. You'll notice that they aren't, however, at least last time I checked, they aren't. So I would be very careful, certainly if you are wanting to go down either road of Butterfest or XFS. I would do an awful lot of testing and a lot of vetting. But at the moment, the fact that it's not particularly popular should be telling you something. So you can certainly blaze that trail if you want to. But I'm not aware of, at the moment, of anybody using either file system successfully. And like I said, the projects I've worked in the past where they insisted on using XFS, it did not work well.
Yeah, my experience is I've never been able to get it to work right.
How big is your file system that you're running out of inodes with the ext4? Unless you're in extremely large, unless you're dealing with an incredibly large number of files, I honestly wouldn't worry about it. Unless you're dealing with a ton of itty bitty files, you're not going to have a problem.
Yeah, for ext4, I've never run into that as being an issue on ext4. I have on 3.
I'd like to point out that there is a rather large cloud company that relies extremely heavily on ext4 for their extremely large distributed file systems, and that's Google. Google uses ext4 as their base file system across their entire prod kernel deployments. And if every Google service that you use uses it. I seriously doubt that you're going to have, and that, again, unless you're dealing with a ridiculous number of small files, I don't think, I find it extremely implausible that you're going to have any problems with inode limits. If you said 200 terabytes, I'd be worried.
Yeah,
But 200 gigs is not, I mean, it's big for embedded, but it's not very big. Again, it's the number of files that you have on that file system that's the issue at that point.
Also, when you create your ext4 file system, you can tell it how many inodes. So it's possible that there's an option that's been set incorrectly, where the number of inodes that you actually allocate haven't been set high enough.
Exactly. But again, you have to know what your upper limit for, if you're dealing with a whole bunch of files that take a very small amount of space, you can run out of inodes, certainly. Yep. But that's typically not the case.
So my answer would be to increase your number of inodes for that particular ext4 file system to try and get it. To try and get it where you want it. And the default is 4 KB, right? Exactly.
Indeed it is.
Right. So it's not 512 anymore. So that shouldn't be an issue, but if it is, it's probably because somebody set it too low. I think if you give it 200, it gives you it does a ratio when you say what the size, when you go ahead and create the file system, it looks at the extents and figures out. The other thing is that's different about it is that it allocates things by extents. So that's quite a bit different as well in the way it's handled. Now you could, I suppose, theoretically run out of extents, but I've never.
Yeah, XFS, butterfest, and ext4 all use extents, so they're all advanced file systems. From that perspective, the big advantage to using butterfest, of course, is that it's a copy on write file system. But,
right.
The other option that you have, well, it is and it isn't. I mean, there's a number of distributions that are using it now. I wish it were adopted more commonly, because butterfest really has an awful lot of very attractive attributes. The problem, unfortunately, is if you look at where the development time is going for the vast majority of people, people are working on XFS and people are working on ext4. Butterfest is relatively less common in the developer world, at least last time I checked. XFS again works extremely well for servers. It's not really tuned for smaller systems. Yeah, exactly.
Right, exactly.
Yeah, you have to use LVM or something otherwise. Again, highly attractive in the embedded space. The major problem with snapshotting, though, is it tends to use a lot of memory, and that's another issue, of course, for embedded. There's always trade-offs.
So you can see here in the layer index, everything starts with meta. There's a whole bunch of them, which depend. Some of them are related to particular things like X or Wayland Weston. Most often, they're actually going to be things that are related to different hardware. A lot of these are BSP layers here. Now, you may have something, for example, if you're trying to deal with one of the hybrids, for example, they're a little bit different in that they have support for the hybrid pieces as well. So you'll find that for both Xilinx and Intel's FPGAs, for example. There's also things such as Wi-Fi for different things as well. So sorry about that. All right. Any other questions at this point? So I might just go ahead and do something else here. Hold on. Let's go over this. All right, so here's Yocto Project. You'll notice that there's a whole bunch of different things here. They have a meta Raspberry Pi that they seem to be taking care of as well. You'll see that these metadata layers that are being done by the prep ARM, AWS, Intel, TI, and Xilinx. And then there's
Can you make
additional ones.
the fonts bigger? It's been hard to read.
Yeah, sure. Let me do that right now. There you go. Is that better?
Yes, it is.
Good. Okay. So you can see there's a number of things. Here's your Pocky config, Pocky contrib as well. So they've got some Pocky also gets contrib from other people. Normally it's done by the core members themselves who take care of that. There's also additional layers here such as AMD and Prescale and Mentor. These other ones. These are other different layers. For example, here's your Intel FPGA. Remember I said for those that are being done as hybrids, for example, you'll see that also for Xilinx, but Xilinx is a platinum member up here. They're contributing a lot of code. For example, currently, I think the kernel developer works for them, for example, who's doing with the BSP layer stuff here. There's some cute things here as well. You'll notice that they're in their own layers, of course, for MetaQt. Rockchip for the various hardware here, for example, some TensorFlow things if you're playing with that. Some virtualization stuff as well. And then there's some additional tools, and there's a whole series of tools here. You'll notice when we talked about it earlier, we have the 3 different versions of the 3 different file system, or rather packaging systems we use. We use, of course, Debs as well as where am I blanking right now? Our RPMs, and then the final one is O-package or iPackage, if you will, which is taken care of by O-package. O-package seemed to be a little bit of abandoned at some point by the outside community, and it was picked up. There's some additional pieces here where they're doing, and it's not in here, it's in the open embedded version, where you'll find such as, for example, unit testing and p-testing and things like that. Those are available from the open embedded group. They're being done over there. So if you need to do some testing for verification, you'll find it there as well. You'll find that we talked about Matchbox. We used to have Sato as the piece. Now we're using Matchbox as the default UI system. So when you build that, you'd build the Matchbox system. That's an XOR piece, if you will. So there's also some additional layers here. And of course, this is the older Sato stuff as well. You'll notice that this is the kernel archive here. We maintain a number of different archives. This is actually in the archive. This isn't actually the layers. They have various kernels. So for example, each one typically supports between 2 and 3 kernels. So you'll have one that's further back. You'll have one that's very recent. You'll have one that's kind of in the middle, and it skips versions. It doesn't necessarily follow with the LTS versions necessarily. It doesn't have to, but oftentimes it tries to be. There is a project within the Yocto project to provide long-term stable. Right now, the cadence is every 6 months or so, so you're having to update. They're looking at, I believe, 2 years. Is that right? Correct me if I'm wrong on that. It's about 2 years, right? For LTS? Okay. Yeah. Not always, Bogdan. Remember that you can be Yocto certified. Your layer can be Yocto certified. Doesn't have to be Yocto certified, but if it is, it will follow the BSPs. It will follow the best practices for the Yocto project if it's certified. You can say you don't want anything but a certified layer, but that's not unusual to have it. Most of them I've seen try and follow the rules and try and give you a layer that makes sense. Probably the hardest initially was getting the BSP layers to be consistent, but since then I've seen that most vendors, I mean, obviously there are some that it took a little while to get them to come in line. I could mention certain ones, but it's probably not necessary to note, but some of them particularly had a hard time with deciding they were going to do it. Mostly it was whatever the vendor that they chose, that the hardware vendor chose to do the BSP, and they were just throwing things over the wall at some point, and they were pretty awful BSPs out there. But most of the time, they seem to be not as much of a problem these days. I think there might be one vendor who still sometimes gives us something that has to be fixed, but most of the time it works pretty good. You're welcome. So there's a whole bunch of things. So you'll notice that that in addition to some of the bigger things, you'll see that Edison, Galileo, and Quark. So for example, Intel contributed those layers for these small ones. There's a whole bunch of other layers as well. One thing to notice, if you really see, I don't see the auto builder in here. I thought auto builder was here somewhere. Okay, maybe it got moved somewhere else. But they used to have an auto builder layer that specifically took care of auto builder type stuff. Yeah, I don't see the auto builder in here anymore. They must have moved it somewhere else. Oh, there it is. Yocto auto builder. There it is, right there. So if you're doing auto building, you can use that. You can use any of the other tools. They all play nicely with, nicely with this. So for example, I use Jenkins CI, but you don't have to. You could use something else if you'd prefer to use it. Exactly. Exactly. Mhm. Let's look over here. Right. So you can see that there's different things that have been moved out. For example, some people require, even though it's been retired, open in Python 2. So even though it's after EOL, there is some support continuing to happen there. But the main developers have moved off and said, we're not going to support this anymore. We didn't want to get rid of it because there's too many embedded things out there in the world that are Python 2. Even though it's no longer supported, we're going to go ahead and maintain that. You'll notice that it looks like about 2 weeks ago, somebody actually made a change to it. So there's still continuing to be things. OP hasn't been used in a while. The meta handhelds, these are all legacy pieces, which are maintained only so that people who have pieces out there can still rebuild it from scratch and it doesn't disappear as far as that goes. Meta open embedded, and then these different pieces are all maintained by the Open Embedded project. You'll notice that this is the OE test pieces. This allows you to do a bunch of test work and verify that things are being done. One of the things that they're working on within the Yocto project itself is our repeatable builds. I think they have a different name for it, but they're essentially repeatable builds. And the intention of this is so that you can know that this is the particular version, it's built, it hasn't changed, and therefore you can use it for building things. Okay, so there's things like that. And then there's the OE build statistics. So if you're running a build cluster, you want to see how things are running, you can append that particular thing. You can add that to your local config, and you can see how long did it take, how many things, did you expect? You expected, this will give you the performance on things, for example, such as how good was your cache hits. So your shared state cache. We needed to build 2,000 things, and gee whiz, we were able to hit, 99% of those came out of the cache. That's kind of important things to note. If you have a lot of churn, you're wondering why things are taking time, you might want to add the OE build stats to your builds and make it so that you can know what's going on within the builds. We use those in particular for our builds here. as far as that goes.